In this video, we're going to be solving the first 40 questions for physics, Jamb 2019. So let's get on with it. Question 1 says the limiting frictional force between two surfaces depend on 1. The normal reaction between the surfaces, 2. The area of surface in contact, 3. The relative difference between the surfaces, and 4. The nature of the surface. So if we have two surfaces, the first being an inclined ground at an angle of theta, and we have a block lying on the ground. Now the frictional force acting between these two surfaces right here is going to depend on, first, the normal force acting across this surface in contact here. Now the normal force is N, which obviously would be a function of the weight of this block. Now the second thing that determines this frictional force is the nature of these surfaces in contact. Now think about it. If you have a car and you drive the car on dry asphalt road, there's going to be enough friction for the car to move normally. But if you drive the same car on a wet road or an icy road, there's going to be a reduction in frictional force, and so the car would slip. So obviously the nature of the surfaces in contact also determine the amount of frictional force. So frictional force is mu n, where n is the normal force here and mu is the coefficient of friction. So in our options here, the normal reaction between the surfaces matters, as well as the nature of the surface. So 1 and 4 is our answer, and our answer here is B. Question 2 says, if a body moves with a constant speed and at the same time undergoes an acceleration, its motion is said to be... Now, the answer here is going to be B, circular motion. But to understand that, let's look at all the kinds of motion here and see what we mean. Now, oscillation motion simply means a repeating motion, where a body repeats the same movement over and over again. An example of that is a pendulum. If we have a pendulum, the pendulum is going to be swinging from a position such as this to a position such as this, and it goes through this position. So it goes back and forth, up and down, and that's an oscillation motion. Now, a rotational motion is when you have a body such as this. It could be a circular body or not, and there is an axis of rotation within the body here. Now, this body keeps moving about this inner axis that it has here. That's a rotational motion. Now, what about a rectilinear motion? A rectilinear motion is simply a body moving in a linear direction to another position. So this body moves from position A to position B. That's a rectilinear motion. Now, what about a circular motion, which we've said is our answer here? Now, consider you have this ball right here, and this ball is tied to a string, and this string has a fixed axis outside of the body here. Now, this body moves in a circular motion if it moves around this axis. But the thing is, if this body moves at a constant velocity around this path, but at every point in time, if this body is here, for example, the direction of motion is going to be in this way. Now, if the body is here, the direction of motion is going to be tangential to the path, which is also this way. And if it's here, it's going to be here. Now, the thing is, although the body is moving in uniform motion, the direction is constantly changing. Now, what is acceleration? Acceleration is defined as the change in velocity over time. The change in velocity over time. Now, don't forget that velocity is a vector quantity, and it composes of speed and direction. So if the speed is changing over time, then the body is said to be accelerating. But if the speed is constant and the direction is changing over time, the body is also said to be accelerating. So either a change in speed or direction would mean a change in velocity, and a change in either of these two over time means the body is accelerating. If the body is in constant speed, but the direction is changing all the time, then it is said to be accelerating. And that's why circular motion is the answer to our question here. Question 3 says, when blue and green colors of light are mixed, the resultant color is cyan, A. Cyan is what you get when you mix blue and green. Question 4 says, a metal rod has a length of 100 centimeters at 200 degrees centigrade. At what temperature will its length be 99.4 centimeters if the linear expansivity of the material of the rod is 2 times 10 raised to the power minus 5 per centigrade? So if we have a piece of rod such as this, and the initial length of this rod here is L0, L0. If you hit this rod is going to expand to a new length, which we can call L1. So the new length is L1. Now the relationship between these two lengths is the new length L1 is equal to L0, which is the original length, into 1 plus alpha. Alpha is the linear expansivity of the material, into T1, which is the new temperature it has been heated to, minus T0, which is the old original temperature. So don't forget that we are dealing with linear expansivity here. So it is important that L0 is the lower of the two lengths and L1 is the longer length. So let's deal with our question. Now we're told that the metal rod is going from 100 centimeters to 99.4 centimeters. So here we can tell that L0, being the lower length, is going to be 99.4 centimeters. And L1, being the longer length, is going to be 100 centimeters. Now T0 is the temperature at 99.4, which is what we've been requested to find. So we're looking for T0. And T1 is the temperature at L1, which we've been told is 200 degrees centigrade. So now if you look at this relationship and you make T0 the subject of the formula, you're going to get that T0 is equal to T1 minus L1 minus L0 divided by alpha L0. So if we plug in our values here, T1 is equal to 200 degrees minus L1 100 minus L0, which is 99.4, divided by alpha. Don't forget that alpha is linear expansivity, which is what we're given here as 2 times 10 raised to the power minus 5 multiplied by 99.4, which is our L0. So you have that this is 200 minus, so the numerator here becomes 0.6, and the denominator here, if you multiply this out, becomes 0.001988. So ultimately you would have that this is equal to minus 101.8 degrees centigrade. Now of all the questions, of all the answers that we have here, the nearest answer here is minus 100 degrees centigrade. So our answer is D. Question 5 says, according to the kinetic molecular model in gases, and then we're given a bunch of options and told to choose the answer. Now before we go through our options, let's look at what the molecular models of solids, gases, and liquids are. For solids, we see here that the particles in a solid are tightly packed, usually in a regular pattern. They vibrate a little bit, but they do not generally move around from place to place. Now for liquid here, we see that although the particles of the liquids are close together, there is no regular arrangement between the particles, and the liquid vibrates about and also slides from place to place generally. Now for gases, which is the final thing we have here, we can see that the particles in the gases are well separated with no regular arrangement at all. They fill every space that is available to them by just bouncing around all the time. Now let's go through our options here. Option A says the molecules are very far apart and occupy all the space made available. Now that's our answer, but let's just look through. The particles vibrate about fixed positions and are held together by strong intermolecular bond. That's solid. The particles occur in clusters with molecules slightly far apart. That's not gases at all. And the particles are closely packed together. They occupy minimum space and are usually arranged in a regular pattern. Obviously, that's solids again. So our answer here is A. They're far apart and they occupy all the spaces that are made available for them. Question 6 gives us this figure with a force of 40 newtons acting down the midpoint of this box. And we've been told to find the value of force acting across this inclined string here for T on both sides. So for all we can tell, this force of 40 newtons is acting at the midpoint of this box right here, which means that the force is going to be split equally between both ends here. So at this point, we can tell that we have 20 newtons acting on this side and 20 newtons acting on this side as well. Now let's learn the resolution of force in a way that we can also apply to any other scenarios. Now when you are resolving force, the best thing to do is to get them to represent each side of a right angle triangle, which is a triangle that looks like this. Now here is going to be our theta, which is going to be the angle we are resolving from. And then we can resolve the forces into the vertical forces, horizontal forces, and the inclined forces. Now we remember the legendary SOHCAHTOA, which is simply a relationship between the sides of our triangle, where sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. Now let's relate that to what we have here. Now let's take half of this structure here. Now 20 newtons here is a vertical force. So this is going to represent the vertical side of our triangle here, which is 20 newtons. Now, this angle here of 30 degrees is going to be our theta here, 30 degrees. And the first word intended we are looking for, which is t, is the inclined angle here, which is going to represent the hypotenuse of our triangle. So t is here. Now, which of these relationships relates the opposite over the hypotenuse? And that's sine. So sine theta is equal to the opposite over the hypotenuse. Now, that means sine 30 degrees, because our theta here is 30 degrees. So sine 30 degrees is equal to, the opposite is 20 newtons, and our hypotenuse is t. So if we make t the sort of formula, all we have to do is cross multiply, and we have that t is equal to 20 divided by sine 30. Now we know that sine 30 is equal to 0.5, so this is 20 divided by 0.5. So t is equal to 20 divided by 0.5 is 40, so 40 newtons. So t is equal to 40 newtons, and our answer here is D. Equation 7 says a train has an initial velocity of 44 meters per second, an acceleration of minus 4 meters per second square. Calculate the velocity after 10 seconds. So usually when I have a question that deals with motion, my first go-to are the equations of motions. And the equations of motion are V equals U plus AT, V equals U plus 2AS, and S is equal to UT plus half AT squared. Now, V is the final velocity, U is the initial velocity, A is acceleration, T is time, and S is equal to distance. So if you look at your questions, you see all the components you have in your question, and then you see which of these equations has all that component as well, and that's going to be your equation. So let's look at this question. For example, we have an initial velocity, which is U, of 44 meters per second. We have an acceleration, which is A, of minus 4 meters per second square. We have a time, T, of 10 seconds, and we'll be requested to find the final velocity of V. So if you look at this, you find that our equation 1 has all these components. We have V, U, and A and T. So let's use that to solve our question. So we have V, which is what we're looking for, is equal to U, which is 44, plus A, which is minus 4, multiplied by T, 10. So our V equals 44 minus 4 times 10 equals minus 40. And 44 minus 4 equals 4. So our V is going to be equal to 4 meters per second. So after 10 seconds of a deceleration of 4 meters per second square, our final speed is going to be 4 meters per second. And the answer here is D. Question 8 says lamps in domestic lightnings are usually in A, series, B, divergent, C, convergent, and D, parallel. Now I think the two options that really apply to these questions are A and D for us to understand the answer. Now let's look at what happens when you arrange the lamps in a house, for example, in series and in parallel. They look like this. So the first one here is arranging lamps in series. Now you have a power source like we have here, and the lights are arranged in series. By arrangement in series, we mean that the same power flows through each of this bulb. So it goes into the bulb, lights this bulb up, and then it goes into the second one, lights it up, and then it goes into the third one. So the same power flows through each of these bulbs. Now, this is not very advisable, because imagine if there's something wrong with this bulb and this bulb is taken out, the first bulb here, which means that the power will not be able to flow into the other two, and so automatically the other two will also be taken out. Now, but look at this case in parallel where power flows across this line here, and then each bulb takes its own power from the direct line that goes through here. Now what happens is, if this bulb is taken out for some reason, now even though the first bulb is off, you would notice that power still goes through the other bulbs, and this bulb continues to shine, and this bulb continues to shine. Now, aside from the fact that if one bulb goes out, the other bulbs will go out, another advantage of having our lamps arranged in parallel is that we can have different switches for each of these bulbs. So we can have a switch attached to this point here. We can have a switch attached here as well, and we can have a switch attached to this point. So we can have different switches for them. But here, if you have one switch here, for example, and you switch off this light, you're switching off everything. So that's not very ideal for a home or domestic setting. So our answer is parallel. Question 9 says, during the transformation of matter from solid to liquid state, the heat supply does not produce temperature increase because... Now, when you have a solid particle that looks, a solid matter that looks like this, that is being heated. Now, so what you have is, if this is the time and this is temperature here, you find that the temperature increases up until a point, which is the melting point, where the temperature remains uniform for a while. And then after melting is completed, the temperature starts to increase again. Now, at this point here where the temperature does not increase, what happens is you have a solid material such as this, well-arranged particles, and they are held together by bonds that we have here. So at the point where you keep heating but the temperature does not increase, what happens is the increase in temperature is actually used to destroy or to break these bonds holding the particles together. So as opposed to increasing the temperature of the body itself, the heat that you're applying to the body is used to break down these bonds. And our answer that corresponds to that is A. A says all the heat is used to break the bonds holding the molecules of the solid together, which is exactly what happens. Question 10 says, in a slide wire bridge, the balance is obtained at a point 25 centimeters from one end of the wire, which is 1 meter long. The resistance to be tested is connected to that end, and a standard resistance of 3.6 ohms is connected to the other end of the wire. Determine the value of the unknown resistance. Now, first, let's look at what a slide wire bridge is. So a slide wire bridge or a meter bridge is used to determine the value of an unknown resistance. So to construct this, we take a wire of 1 meter, which is what we have from here to this point here. And we take two metallic L-shaped metals, which is what we have here and here. And then we place a single metal sheet between those two metals with a gap at each end. So we connect some EMF source to this whole setup. So between these two spaces here, we have a resistance box, which we know, a known resistance, is connected here at point S. And for R here is the unknown resistance that we're trying to, let's call this the unknown R that we're trying to determine. Now, between these two, we have a galvanometer here. We connect the galvanometer to this metallic strip that is connecting these two resistors. At the other end of the galvanometer, we connect a knife edge. Now, this knife edge is used to touch this metal wire, and then we move the knife edge across the wire until we get a reading of 0 on this galvanometer. Now, when we get a reading of 0, we are said to have found the balance. Now, let's designate the point at which we get the balance on the wire as point D. So the formula is going to be that AD, which is the distance between this end of our galvanometer to the point where we get the balance, divided by DC, which is the distance between the knife edge point and the other end here, DC, is equal to our R, which is the unknown resistance, divided by S, which is the known resistance. So we can make R, which is the unknown resistance, the solid formula, and find the value. So now that we know that, let's look at the question again. So the question says the balance is obtained at a point 25 centimeters from one end of the wire, and the resistance to be tested is connected to that end. So the resistance to be tested is R. So we know that the distance between A and D is 25 centimeters, which means this other end is 75 centimeters. And we know that the resistance here is of value 3.6 ohms because we'll be giving that in the question as well. So let's plug those into our formula here. AD is 25 centimeters, DC is 75 centimeters, and this is equal to R, which is what we're looking for, divided by 3.6. So if we cross multiply, we have that R is equal to 25 multiplied by 3.6 divided by 75. And this is equal to 1.2 ohms. So our answer here is D. Question 11 says electrons were discovered by who? Electrons were discovered by J.J. Thomson, that's C, in 1879 when he was studying the properties of cathode ray. Question 12 says which of the following is or are limitations of the Rutherford atomic model? 1. It's applicable when energy is radiated as electrons are revolving. 2. It is applicable when energy is radiated in a continuous mode. 3. It is applicable to an atom with only one electron in other shell. If you are not familiar with the Rutherford's atomic model, it looks like this. Rutherford's atomic model simply states that the majority of an atom's space is empty and that most of its mass is concentrated in the center, which is the nucleus we find here. And this center is positively charged because of the protons that it contains. It also says that the electrons surrounding the nucleus, which is what we have here, are negatively charged, and they travel continuously around the nucleus in a path that is called orbits in high speed. Now, so the limitations of this model. One of the limitations of this model is that Maxwell's equation tells us that an accelerated charged particle would always emit electromagnetic radiations. And as we see, the electrons are said to be continuously moving here and changing direction, so they are accelerating around the nucleus. Now, which means that they will also be emitting radiation. Now, calculations have shown that the radiation that will be emitted by these electrons would collapse this nucleus. So Rutherford's atomic model did not take into consideration this radiation emission that will be taking place from the continuous motion of the electrons, and thus it did not explain why this atom is stable despite this radiation. Now, the other limitation of this model or theory is that it did not address the issue of electron arrangement. Now, we know that for an atom that has multiple electrons, their electrons are arranged in different ways in different orbits. So the question says, what are the limitations? First, it is applicable when energy is radiated as electrons are revolving. That's what we just explained about the radiating emission. It is applicable when energy is radiated in a continuous mode. That is also applicable. Now, it's applicable to an atom with only one electron. Now, we said electron arrangement for multiple electron having atoms. Now, for an atom that has only one electron, the Rutherford atom has no limitation concerning that. So our answer is 1 and 2, and that is C. Question 13 says, 3 resistors with resistance 200 ohms, 500 ohms, and 1 kilo ohms are connected in series. A 6-volt battery is connected to either end of the combination. Calculate the potential difference between the ends of the 200 ohms resistance. So here we have 3 resistors connected in series. So the first resistance, the second one, and the third resistor. Now, we have a battery of 6 volts connected to this. So we have 6 volts battery, we have 200 ohms here, we have 500 ohms, and we have 1000 ohms. Now, the first thing we need to do is to calculate the current that is flowing across this circuit as a whole. Now, we know that voltage is equal to IR, which means that if we make I the circle to the formula here, we have that I equals V over R. Now, the R here to calculate the current across the entire circuit is the R equivalent. Now, when you have resistance or resistors connected in series, the R equivalent is equal to R1 plus R2 plus R3, which means that our R equivalent in this case is equal to 200 ohms plus 500 ohms plus 1000 ohms, and this is equal to 1700 ohms. So our current, the current flowing across this circuit is I equals the voltage 6 divided by 1700, and this is equal to 0.00353 amps. Now that we know the current flowing through the entire circuit, now to calculate the potential difference at the ends of the 200 resistance, to calculate the potential difference across this resistance alone, we have that V is equal to IR. In this case, the resistance is that which we're considering only, that is 200 ohms. So V is equal to current of 0.00353 multiplied by 200 ohms. And this is equal to 0.71 volts. So our answer here is A. Question 14 says, in semiconductors, the carriers of current at room temperature are. Now, for normal conductors, conduction is done by free electrons only. However, in semiconductors, conduction is done by electrons and holes. So our answer here is B, electrons and holes. Question 15 says, when the temperature of a liquid is increased, what happens to the surface tension? Now, we know that surface tension is caused by a cohesive bond between the molecules of a liquid at the top of that liquid. Now, when you heat up the liquid, what happens is that the heat weakens this bond between the molecules here. So that causes the surface tension to decrease. So when the temperature of a liquid is increased, the surface tension decreases. Our answer is B. Question 16 says the distance between an object and its real image in a convex lens is 40 centimeters. If the magnification of the image is 3, calculate the focal length of the lens. So this is our convex lens right here. and this is our object here. So if the size of our object is HO, and this is the magnified image here, and we represent the size of our image as H1, that's the size of the image. So the distance between our object and the lens is designated as U. And if the distance between the lens and the object and the image is designated as V. So the formula for our focal length is 1 over F is equal to 1 over U plus 1 over V. We also have that the formula for our magnification M, is equal to the size of our image, which is H1, divided by the size of our object, which is HO. This is also equal to V over U. So from the question, we're told that the distance between the image and its real image is 40 centimeters. So we know that the distance between the object and the image right here is 40 centimeters. So here we know that U plus V is equal to 40. And we're also told that the magnification of the image is 3. So we know that M is equal to 3. And we know that M is equal to V over U. So from here, we can tell that V is equal to 3U. If we just cross multiply here, we have that V is equal to 3U. Now, if we put this value into the equation here, we can be able to solve for U. So we have that this becomes U plus, now V equals 3U equals 40. U plus 3U is equal to 4U. So 4U is equal to 40. And if we divide both sides by 4, we have that U is equal to 10. So if U is equal to 10, and we put that back into this, we have that V is equal to 3 multiplied by 10. And so we know that V is equal to 30. Now we have our U and we have our V, but we're requested to find the focal length, which is F. So we'll use this formula right here. So we have that 1 over F is equal to 1 over U plus 1 over V. And this is equal to 1 over U is 10 plus 1 over 30, which is our V. So this is equal to, we have it an LCM of 30. So 30 divided by 10 is equal to 3. 3 times 1 is 3. And 30 divided by 30 is 1. 1 times 1 is 1. So this is equal to 4 over 30. Now, but don't forget that this is 1 over F. So F is the inverse of this, which is 30 over 4. And this is equal to 7.5. So our answer is 7.5. And if we look at our options here, 7.5 is B. Question 17. A ray of light passes through the center of curvature of a concave mirror and strikes the mirror. At what angle is the ray reflected? To understand the answer we'll be getting, let's first look at what happens when we have a reflection on a plane mirror. So if we have our plane mirror here, and we have an incidence ray coming in, such as this. Now, how do we decide the angle of reflection? So first we find the normal to this mirror here, which is 90 degrees to the surface, to the reflective surface itself. Now this angle here is called the angle of incidence, the angle between the incidence ray and the normal plane to the mirror. Now the angle of reflection is going to be exactly the same as the angle of incidence. So these two angles here are going to be the same, but the deciding factor here is the normal to the reflective surface. So let's try this on a curved mirror and see how it works. So if we have our concave mirror like we have here, the F point here is the focal point, and the point labeled C here is the center of curvature. The center of curvature is simply the center of the circle which this mirror is a part of. So if this mirror were to be a full circle, this will be the center. Now, let's take this first ray here as an example. How do we determine what the reflection angle is? Now, if you look at the ray coming in this way and it hits the mirror at this point. So to get the angle of reflection, what we do is we draw in a line tangential to the curvature of the mirror at this point. And from here, we can draw a normal to this. And from here, you can see that the angle of incidence here is the same thing as the angle of reflection here. Now, what about this ray here, which is the one that passes through the center of curvature? If you look at this ray, it hits the mirror at this point. Now, let's draw a tangent to the mirror as well. If we draw a tangent to the mirror and we draw a normal to the mirror, the normal goes exactly along the axis of the ray itself. Now you would see that the angle of incidence here is 0 because the normal and the ray lie on the same axis. So therefore, the angle of reflection as well is going to be 0. So in other words, so if a ray of light comes through the center of curvature of a concave mirror and it hits the mirror, the ray is going to be reflected back exactly along the same path. So the angle between those two is going to be 0. So our answer here is C. Question 18. The pinhole camera produces a less sharply defined image when... This is what a pinhole camera looks like. The pinhole camera works by allowing light through a hole called the aperture, and the light falls on some photographic paper at one end of the camera and forms an image. As you can see, the light at the top of our object here passes through the pinhole and falls at the bottom of the paper here, while the light at the bottom of the object passes through the pinhole and falls at the top of the paper here. So the image we have is inverted. Now the size of this aperture is very important to the quality of the image that we get. If this aperture is to be too wide, we would have light coming from all sources, and so we would not have a very clear image formed. But if the smaller the camera, the hole of the camera, the sharper the image we get. So our answer here is A. Pinhole camera produces a less sharply defined image when the pinhole is larger. Question 19 says, a straight wire 15 centimeters long carrying a current of 6 amps is in a uniform field of 0.4 Tesla. What is the force of the wire when it is at right angle to the field? So for a current carrying conductor in a magnetic field, the magnetic force is given by F is equal to B I L sine theta. Now B is magnetic flux. The I is the current flowing through the conductor. L is the length of the conductor. And theta is the angle of the magnetic field. So from our question, we know that the magnetic flux is given as 0.4 Tesla, and the current flowing through the conductor is given as 6 amps. The length of the conductor is given as 15 centimeters, and we're told that the field is at right angle, so this is 90 degrees. So if we plug this into our equation, we'll have that F is equal to B 0.4 multiplied by I, which is 6, multiplied by L, which is 0.15 meters, sine 90. So our F is equal to 0.4 times 6 times 0.15. We know that sine 90 is equal to 1. So our answer here is equal to 0.36 newtons. And the option here is option C. Question 20. The pitch of a screw jack is 0.5 centimeters and the arm is 60 centimeters long. If the efficiency of the jack is 75 divided by pi%, calculate the mechanical advantage. Now a screw jack looks something like this. Now it is operated by turning this handle that we have here over a complete circle. And when that happens, this jack itself rises up and is used in lifting heavy objects. Now, like all machineries, we know that the efficiency is equal to the output divided by the input multiplied by 100. Now, the input of the screw jack is the effort we make in turning this handle over a complete circle. And that effort is what we call the velocity ratio. So our input is the velocity ratio. The velocity ratio is given as 2 pi r over p, where r here is the length of this our arm here, and p is the distance between the screw threads in the jack here. So here we'll be giving r as 60 centimeters and we're giving our pitch as 0.45. So this is the input, and our output is what we call the mechanical advantage for the screw jack. This is our output. So if we have, from our equation here, we have that efficiency is equal to output, which is the mechanical advantage, divided by the input, which is the velocity ratio, multiplied by 100. And now if we want to make mechanical advantage the subject of the formula, since that is what we've been requested to find in our question, mechanical advantage is going to be equal to, if we cross multiply, we have efficiency multiplied by velocity ratio and we bring down 100 here, so divided by 100. So if we plug in our values, we have the mechanical advantages. The efficiency is 75 divided by pi. So we have 75 over pi multiplied by our velocity ratio, which is 2 pi multiplied by r, which is 60, divided by p, which is 0.45, and we divide by 100, that's multiplied by 1 over 100. So pi here cancels out pi here, and we have that 75 multiplied by 2 multiplied by 60 is equal to 9,000, and 0.45 multiplied by 100 is equal to 45. So 9,000 divided by 45 is going to be equal to 200. So the mechanical advantage here is equal to 200. Our answer here is C. Question 21 says, when the downward current flows in a straight vertical conductor, the direction of its magnetic field at a point due north of the wire is. Now, when current flows through a conductor, it produces a magnetic field. To determine the direction of this magnetic field, we would need to know the right-hand rule. This is a pictorial representation of the right-hand rule. Now, if you take a pen and you wrap your right hand around the pen like you can see in the picture, with your thumb across the axis of the pen. Now, the right-hand rule says that if the current flows in the direction of the thumb, which is what we see here upwards, the resulting magnetic field will flow in the direction of the fingers around the pen. So if we were to represent these directions in the cardinal point, we'll say the current is flowing in the north direction, and the direction of magnetic field is this way, which is east. But the question says if the current is flowing downwards. So let's invert this picture and see what we'll get. Inverting this picture shows us a case where the current is flowing downwards, as you can see here. So if the current is flowing downwards, that means the magnetic field is going to be flowing in this direction, which we can see is west. So our answer here is D. Question 22 says, aluminium is sometimes used as the leaf of an electroscope because... Now, an electroscope looks like this. Now, this instrument is simply an instrument that is used to detect small electric charges. So what you see here is simply a steel casing that has glass on the side so that we can see into the casing. And at the top here, you have something like a brass plate, and you also have a brass rod leading into the glass. Now, at the end, which is what we have here, is made up of 2 gold leaves. Now, these gold leaves are touching because at this point, they are uncharged. Now, if we move to the right side here, if you place a positively charged material on the brass plate here, for example, now the charge travels through the rod into the leaves. And so both leaves become positively charged. And don't forget that like charges repel. Now, the repulsion caused by the like charges in the 2 leaves is why they repel each other and open up. And that is how you use this instrument to detect charges. Now, the reason why we use gold or sometimes aluminum here is because we need something that can conduct charges but can also be made into very, very thin sheets. There are many things that can conduct charges, but gold and aluminum are 2 materials that can be made into very, very thin sheets, thin enough to be able to detect very small charges. So the answer here is going to be D, because aluminum can be converted into thin sheets. Question 23. The diagram above represents the stress-strain graph of a loaded wire. Which of these statements is correct? Now let's look at this graph in itself. Now the region between the origin O here and I is called the region of proportionality. Now the region of proportionality is simply that region where as you apply load to the material still obeys Hooke's law. Now I here is what we call the elastic limit. Now, the elastic limit is the point where the material stops obeying Hooke's law. However, if you remove the force of loading from the material still goes back to its original length. Now, J here is what we call the yield limit. The yield limit is the point where beyond which the material no longer goes back to its original position. When the material is loaded and it goes beyond the J point, you can start to notice some plastic behavior in its properties. Now, K is what we call the ultimate stress point. Now, the ultimate stress point is simply the maximum strength that the material has to bear before breaking. And L is what we call the breaking point. This is the point where the material just shatters and breaks as we continue to load it. So let's look at our options and see which one of them is true. Option A says at J, the wire becomes plastic. Don't forget that we begin to notice plastic properties at the points beyond J. So this isn't entirely true. B says J is the yield point. Obviously, that is what we have here. J is the yield point, so B is the answer. Now, L is the elastic limit. No, L is the breaking point. And at K, the wire breaks. No, the wire actually breaks at L. So our answer here is J. Question 24 says a supply of 400 volts is connected across capacitors of 3 microfarads and 6 microfarads in series. Calculate the charge. The formula for charge, Q, is equal to VC, where V is the voltage and C is the capacitance. Now, for capacitors connected in series, so if we have two capacitors like we have in the question connected in series, now the C here is not the individual capacitance, but the equivalent capacitance. And to find the equivalent capacitance of capacitors in series, the formula is 1 over CT equals 1 over C1 plus 1 over C2. If the capacitors were connected in parallel, it would simply have been CT equals C1 plus C2. But since we're dealing with capacitors in series, this is our formula. So 1 over CT is equal to 1 over 3 plus 1 over 6. And this is equal to, we have an LCM of 18, and this is 6 plus 3. So this is equal to 9 over 18. So 1 over CT is equal to 9 over 18. 9 goes here once, 9 goes here twice to give us half. So our equivalent capacitance is going to be the inverse of this, which is 2. So this is 2 microfarads. So if we bring this into our equation here, we have that Q, the charge, is the voltage 400 volts multiplied by 2 times 10 raised to the power minus 6. Don't forget that this is microfarads, and micro is 10 raised to the power minus 6. So Q is equal to 400 times 2 is 800 multiplied by 10 raised to the power minus 6. And if you're familiar with your indices, you know that this is the same as 8 times 10 raised to the power minus 4 coulombs. So our answer here is A. Question 25 says a vibrator causes water ripples to travel across the surface of a tank. The wave travels 50 centimeters in 2 seconds, and the distance between successive crests is 5 centimeters. Calculate the frequency of the vibrator. Now we know that the formula for the velocity of a wave is the wavelength divided by the period, which is the same as the wavelength multiplied by the frequency. Now from here we can tell that to find the frequency, all we need to do is divide the velocity by the wavelength. So frequency is equal to velocity over wavelength. Now we need to find the velocity and the wavelength. Now from the question, we're told that the wave travels 50 centimeters in 2 seconds. So we can tell that the velocity is equal to distance over time. So the distance is 50 centimeters and the time is 2 seconds. So the velocity of our wave is 25 centimeters per second. Now what about the wavelength? Now the question tells us that the distance between successive crests is 5 centimeters. And we know that by definition, the distance between any 2 successive points on a wave is the wavelength. So our wavelength is equal to 5 centimeters. So now we have all we need to calculate our frequency. Our frequency is, don't forget, velocity over wavelength. So the velocity here is 25 and the wavelength is 5. So our frequency is 5 divided 25 to give us 5. And the unit for frequency is hertz. So our frequency is 5 hertz. Our answer here is A. Question 26 says a thermocouple thermometer is connected to a millivoltmeter, which can read up to 10 millivolts. When one junction is in ice at 0 degrees centigrade and the other is in steam at 100 degrees centigrade, the millivoltmeter reads 4 millivolts. What is the maximum temperature which this arrangement can measure? So to answer this question, we're going to be learning some interpolation. Now, how do we do that? Let's have 2 scales. Let one scale represent the scale of the millivoltmeter, and the other scale represents the temperature that we're trying to measure. So on the left here, if we have the millivoltmeter, we have that the minimum of the millivolts is 0 millivolts. And we're told that the maximum the millivolts can read is 10 millivolts. So we have the maximum here to be 10 millivolts. On the other hand, on the temperature, we know that the minimum of the temperature is 0 degrees centigrade. And the maximum is what we're trying to find, because the question says, what is the maximum temperature this arrangement can measure? So the maximum temperature that can be measured, let's designate that as X degrees centigrade. Now we're told that when the thermometer is in a steam of 100 degrees centigrade, which should be somewhere here, for example, the millivoltmeter reads 4 millivolts. So 4 millivolts corresponds to 100 degrees centigrade. Now to find the maximum temperature, we know that this x degrees centigrade is going to correspond to 10 millivolts, which is the maximum on the millivoltmeter. So to handle this kind of setup, what we do is, let's deal with the temperature side first. We have x, which is the maximum temperature, minus 0, which is the minimum, divided by the temperature that we know, 100 degrees centigrade, minus the minimum, which is 0. Now this should be equal to, relating it to the scale on the millivolts, we'll also have the maximum, which corresponds to x, that's 10 millivolts, minus the minimum, which is 0, divided by the measurements that we know, which is 4 millivolts corresponding to the 100 we have here. So that's 4, minus the minimum, 0. So that's 0. Now we can go ahead and solve for x. Now, x minus 0 is simply x. 100 minus 0 is 100. 10 minus 0 is 10. And 4 minus 0 is 4. Now, I went through the pains of writing out the minus zeros here because you might also have a scale where the minimum is not 0. It could be anything. So you have to, this is how you go about it. Now, if we solve for x, all we do is cross multiply, and we have that if we bring 100 there, this is equal to 10 times 100 divided by 4, which is equal to 1000 divided by 4, and this is equal to 250 degrees centigrade. So the maximum temperature that can be measured, x, is equal to 250 degrees, which is C here. Question 27 says an alternative current can induce voltage because it has an alternative current source induces voltage because of the varying magnetic field. So our answer is B, not because of the ripple or because of the high peak torque or weaker magnetic field, but simply because the magnetic field is varying, and that is what induces voltage. So our answer here is B. Question 28 says, when water is boiling, what happens? Now, the definition of the boiling point is the temperature at which the vapor pressure of a liquid equals the external pressure, that's the atmospheric pressure. Now, what happens then is that the liquid starts to change into the gaseous form. So for water, boiling point is the point where the water begins to change to steam. And our answer here is D. Question 29. A mixture of blue and red pigments when illuminated by white light would appear. Well, this simple color triangle could help. And what happens here is when you mix blue as we have here by red as we have here, you'd see that what we have is purple. So our answer here is C, purple. Now you can look at this and tell that when you mix blue with yellow, you're going to have green. So you can look at this triangle and use it in answering other such questions that you might have in the future. Question 30 says, water and kerosene are drawn respectively into two limbs of a Hertz apparatus. The density of water is 1 gram per centimeter cube, and the density of kerosene is 0.8 grams per centimeter cube. If the height of the water column is 20 centimeters, calculate the height of the kerosene column. Now, Hertz apparatus is simply a device that is used for comparing the density of liquids. Now, the setup looks something like this. On the left side, we have water in a container rising up a column, and on the right side, we have kerosene in a container also rising up a column. Now, both liquids will rise up the column as a function of the atmospheric pressure and their densities. Now, the Hertz apparatus works on the principle that the same pressure is acting on both columns. And so, since we know that pressure in liquids is given by H rho G, and since the pressure is constant in both cases here, we'll have that H, which is the height of the water, and multiplied by the density of the water multiplied by G, should be equal to the height of the kerosene multiplied by the density of the kerosene multiplied by G. Here we have that our G, which is due to gravity, is the same. So G can cancel out the G here. And we can say that H rho of water should be the same as H rho of kerosene. So here we have that the height of water is 20 centimeters. We're given that here. So HW is 20 multiplied by the density of water, which is given here as 1. So the density of water is 1. Now the height of kerosene is what we're looking for. That's what we've been requested to find. So we leave that as HK multiplied by the density of kerosene. And the density of kerosene is given that as 0.8 grams per centimeter cube. So here we can make HK the sort of the formula simply by dividing both sides by 0.8. So we have that HK is equal to 20 times 1 divided by 0.8. And this is equal to 20 divided by 0.8. So the height of the kerosene column is simply going to be 25 centimeters. So our answer here is D. Conduction of heat is best done in a solid material such as a metal. Now if we assume this is a metal, in this metal we have particles of these metals arranged in a fixed position. Now these particles vibrate from time to time, and the vibration of these particles is how heat transfers through the particles. So as these particles vibrate, they come in contact with one another, and as they do so, heat is transferred from one end to the other end of the particle. However, for very good conductors such as metals, that's not the only thing that happens. In this metal, we also have what we call free delocalized electrons. Now, these electrons travel across the metal up and down, and that makes the heat flow through this metal very fast. So when conduction happens in a very good conductor such as metals, it actually happens through free electrons. So our answer here is A. Question 32 says, when a girl moves towards a plane mirror at a speed of 4 meters per second, the distance between the girl and her image reduces at a speed of. So if we have a plane mirror right here, if this is our mirror, and we have a girl standing at a distance L from the mirror, so this is distance L. Now we know that the image of this girl from the mirror is also going to be on the other side. However, it's also going to be at a distance L, just as the girl herself. So we know this by law that the image of an object is the same distance from the mirror as the object itself. So if this girl moves towards the mirror to a new position, let's say she moves towards the mirror to this new position, and the distance between her is D, which means that the image would also move to a position which is also equal to D. So essentially, what we're saying is that they move at the same distance over the same time. So which means that the speed of the image towards the mirror is exactly the same as the speed of the object towards the mirror. Now let's think about it this way. If the image were to be stationary and the girl was moving towards the image, so the speed is 4 meters per second. Now this is if the girl were moving towards her image and the image were to be stationary. But the image is not stationary. The image is also moving towards the mirror at the same speed as the girl, 4 meters per second. So the distance between the girl and her image is reducing at the speed that the girl moves towards the mirror and the speed at which the image also moves towards the mirror. And that will be the 4 meters per second that the girl moves herself and the 4 meters per second that the image moves in the other direction. So our answer here is 8 meters per second. C. Question 33 says, which of the following media allows transmission of sound waves through them? 1. Air. 2. Liquid. 3. Solids. Now, sound wave is a mechanical wave. And by mechanical wave, we mean a wave that requires a medium for its propagation. Now, sound can travel through air, liquids, and solids. They are all mediums that propagate sound. The only difference is that it travels faster in solids than in liquids, and sound travels faster in liquids than in air. But sound travels through all these mediums. So our answer here is 1, 2, and 3, which is D. Question 34 says, the Earth's gravitational field intensity at its surface is about. Now we're requested to calculate the gravitational field intensity of the Earth. Now the formula for that is G equals capital G, capital M divided by R squared, where small g is the gravitational field intensity. The big G is the gravitational constant. And we're given the gravitational constant here as 6.7 times 10 raised to power minus 11 Newton meter square per kilogram square. And the M, capital M here, is the mass of the Earth. And we're also giving that here as 6 times 10 raised to power 24 kilograms. And R is the radius of the Earth. And we're giving that here as well as 6.4 times 10 raised to power 6. So if we calculate that, we'll have that our G, which is gravitational field intensity, is equal to the gravitational constant, big G, which is 6.7 times 10 raised to the power minus 11, multiplied by the mass of the Earth, which is 6 times 10 raised to the power 24, and we'll divide that by the radius of the Earth, which is 6.4 times 10 raised to the power 6 squared. So if we solve this, we would have 6.7 times 6 is equal to 40.2. 10 raised to the power 13 is 40.96. Have 10 raised to the power 12. So 40.2 divided by 40.96, that will be equal to 0.9814. And 10 raised to the power 13, so 12 cancels out 13 here to leave us with 110. And finally, we have that G is equal to 9.814 Newton per kilograms. So our answer here is D. Question 35 says 1 Newton times 1 meter equals what? What is a Newton? Newton is the unit for force. And we have meter, which is the unit for distance. So we know that force times distance is equal to work done. And the unit of work done is joules. This is also energy. So our answer in this case is equal to 1 joule, B. Question 36 says a man on the bench will exert the greatest pressure on the bench when he does what? Now we know that pressure is equal to force over area. So from here, if we want to increase the pressure, which is our aim here to get the greatest pressure, we either increase the force, or we reduce the area. Now, since the man is going to be applying a constant force, he's not getting fatter or thinner, so he's going to be applying a constant force. So the only option we have here is to reduce the area as much as possible. So the lower the area we have, the higher the pressure. Now let's look at all these options and see which one provides the least amount of area. It says if he lies on his back. Obviously, if he lies on his back, he's going to be lying across a large area. If he lies on his belly, not so small. If he stands on both feet, or if he stands on one toe. Now, obviously, you know that standing on one toe gives the least amount of area as against standing on both feet. So our answer here is going to be, that is where we have the lowest area, and that is how we're going to be able to generate the highest pressure. Question 37 says, a force of 6 newtons acts horizontally on a stationary mass of 2 kilograms for 4 seconds. The kinetic energy gained by the mass is... So we know that kinetic energy is equal to half mv squared. Here, where m is the mass and v is the velocity. So here we have our mass as 2 kilograms. We've been given that in the question. However, we do not have our velocity. And we also know that force is equal to mass times acceleration. But our acceleration is equal to the change in velocity over the time taken to reach that velocity. So if we cross multiply, leaving our change in velocity on this side, we would have that t goes over here to have force multiplied by time, and m will come over here. So we'll divide this by m, and we'll have our change in velocity. Now the change in velocity is simply the final velocity minus the initial velocity. But in the question, we're told that the object was stationary. So we know that the initial velocity is 0. So v final minus 0 is still v. So change in velocity can simply be our velocity here. So we have that force times time over mass is equal to our v. So now we have an expression for our v, which is what we have here. Now we know the force that acts is 6 newtons. We know the time, which is 4 seconds, and we know the mass of the body, which is 2 kilograms. So we can put this into our equation for the kinetic energy here and solve. So our kinetic energy then becomes half of the mass multiplied by the v, which is now ft divided by m squared. So this becomes half multiplied by our mass, which is 2 kilograms, multiplied by our force, which is 6 newtons, multiplied by the time, which is 4 seconds, divided by our mass, which is 2, all squared. So this is equal to 2 cancels out 2 here, 2 cancels out 6 here to give us 3, And we have 3 times 4. So 3 times 4 is equal to 12. Now 12 squared is equal to 144. So our kinetic energy is 144 joules. And our answer here is B. Question 38 says neutrons were discovered by who? Neutrons were discovered by James Chadwick in 1932. So our answer here is C. Question 39 says gases conduct electricity under what conditions? Now, generally, gases are poor conductors of electricity. In fact, mostly they are considered insulators. We know that to conduct electricity, we need electrons to travel across the material. When gases are at high pressure, now at high pressure, they are very tightly packed. What this means is that the mean free path for the electrons is very low, and there is not enough energy or path for the electrons to travel. So in this case, gases do not conduct electricity at high pressure. At high pressure, they don't conduct electricity. However, at low pressure, what happens is that the particles of the gases are less tightly packed. So the free electrons have enough energy, space, and time to be able to accelerate across the entire gas. Now, if you apply a high voltage to this low pressure situation, you would see that the gases will start glowing, and that signifies the conduction of electricity. So gases will only conduct electricity at low pressure, however, not very low, and high voltage. So our answer here is low pressure and high voltage. That's D. Question 40 says the lead acid accumulator consists of. Now, the lead acid accumulator is one of the earliest batteries, and the setup looks like this. And as we can see, it has a positive electrode of lead oxide, which is PbO2 we have here, and a negative electrode of lead itself. And the electrolyte is made of sulfuric acid, which is the H2SO4 here. So our option says A, lead as the positive electrode. That is wrong because our positive electrode is lead dioxide. B says lead acid as the negative electrode. That's also wrong because our negative electrode is lead. C says hydrochloric acid as the electrolyte. Now our electrolyte is H2SO4, which is sulfuric acid or hydrogen tetrozosulfite. So our D is the right answer. So our answer here is D. Now we've come to the end of this part of our question and answer session. Thank you for staying with me. If you liked this video, please share it, subscribe to the channel, and join me on the next one.